TeraSky is a global system integrator in the last years. We're working closely with a lot of our customers about edge technologies. We are major partners of HashiCorp globally. We are, in the last year, we got the EMEA Partner of the Year. And Lev, our CTO, couldn't be here today, is an HashiCorp ambassador globally. He does a lot of evangelism around the HashiCorp products and works closely with HashiCorp and with our customers. TeraSky is working in the world with most of the cloud infrastructure with AWS and GCP, working in the last couple of years with VMware, and last year we got Global Partner of the Year. And the main topic for us is how we can assist customers to grow and build solutions for them based on our partner technologies. Can you, next slide, please? In the last year, we worked closely with HashiCorp in order to improve what we can do with our customers and how we can assist our customer adopt more the HashiCorp frameworks as well. And as part of it, HashiCorp released also more competence related certificates for companies. And I'm happy to say that last month we got 2 of the competencies that were available, which is the HashiCorp security competency and the infrastructure competency. And we are the only hyper specialized partner in the world that got both of them together, which is, I can tell you, it's a lot of effort from our side and definitely a lot of effort from the HashiCorp team that worked with us on that. So it's a major milestone. We invest a lot in the partnership with HashiCorp. We invest a lot of how we can assist customers to progress in the cloud journey as part of what is happening in the world, regardless if it's public cloud or private cloud. And of course, we are discussing at the end that we want to provide a single solution for a customer to adopt, unrelated to which infrastructure it is. So this is a little bit about TeraSky. Of course, we would be happy that you reach out afterwards also for us for additional questions. And Sarah, the stage is yours.
Thanks so much, Tal. I'm absolutely thrilled to be here doing this event with TeraSky. I had the pleasure of meeting them a few weeks ago in person in Israel, and just can't say more. Yeah. Can't say better things than they're an absolute dream to work with. And yeah, I think if you work with them, then you'll get to witness that for yourself. Also, working jointly with AWS and AWS Marketplace, I'm really excited to see where all of these things go. Just to give you a little bit of background, my name is Sarah. I'm the field CTO in Europe, Middle East, and Africa for HashiCorp. And what that means is I go out and talk to a lot of our strategic accounts about challenges that they're encountering, both in the market with technologies, et cetera, and help them solidify their overall tech strategy, whether that be a more developer velocity focus or again, security focus. I come from a software engineering background before I decided to pivot myself into security. So for me, it's important to be able to reunite those two things, because I think we're at a stage within development, just in general, that we can no longer just say no in terms of security. It has to be about how are we going to augment the experience for the developer and make sure that the organization itself is also growing in terms of their security footprint and reducing that attack surface. Before coming over to HashiCorp, I actually ran a secrets management program for one of the large banks here in the Netherlands. So secrets management is really something that's near and dear to my heart, as is containerization. Because having worked in that, I've started to see, where are all of those gaps and how do those gaps line up. So a very natural thing for me to come to talk to you about today is kind of this idea of zero trust and where does it stem from. It's something that has a lot of buzz on the market right now. And I want to make sure that that buzz actually translates into something that's actionable and valuable for an organization, because if we just leave it as a buzz, it becomes, just another one of those things that kind of flies by, but we don't really get the impact that it should have basically. And I think that it's something that's quite important, generally speaking, like I said, to the developer community, but also to organizations, CISOs, any sort of governance. How do we reunite all of these things to make sure that everybody is getting what they need at the speed that they need to? If we look towards McKinsey, for example, they're saying that there's a direct correlation between the speed of an iteration and the performance of a team. So the higher performing team, the faster the iteration. So how are we doing that in a way that development teams can consume from us and increase their security posture? And as we see these companies moving to the cloud, what we're starting to understand is we initially had that private data center, and that was kind of the end all be all. Once we started adding cloud into the mix, it became a lot more complex. And we're also starting to realize that that private data center probably isn't going to go away. And a lot of that is due to the sheer fact that there's a lot of legislation and a lot of uncertainty around what is going to happen. How is that going to evolve? Where are the data sovereignty laws going to reside? If you have, for example, an American residing in Europe who's working with an Israeli company, what are the implications for that? And we need to be able to have the flexibility then, based off of this zero trust idea and data sovereignty, to be able to switch those things based off of any regulation at any given time. And we see that about, I think it was 51 to 52% of companies within the next 6 to 12 months are going to be in this multi-cloud environment. Whether you consider that to be private cloud, public cloud, they're going to have some mix or agglomeration of these things. So when we look at security and what was happening in the security space, it used to be relatively simple when we had a private data center, because it was a physical place that we could drive to, park our car, walk in the front door. If we wanted to be connected to the internet at any point in time, we would have to ask our networking guys to go ahead and plug in, that cable to give us internet access to our server. And if we wanted to do something silly like plug an HSM directly into the internet, our networking guys were going to say, yeah, no, you can't do that. And that would kind of be the end of that story. We knew everything was relatively secured, and that barring an insider, everything could more or less be trusted. And we inherited a lot of trust off of various machines or servers or other systems just based off of this fact that we knew we could trust what was on the inside. But now, again, we're evolving. We're adding in public cloud. Sometimes we're attaching our systems of engagement, which are these really dynamic applications that have really spiky traffic flows, for example, and we're connecting them to our systems of record, which are our older golden sources, databases, et cetera. And that trusted perimeter that we used to have no longer exists, because that's become completely logical. And if it's completely logical, that means there's room for error because it's a human who's putting it in place. For example, I've seen various key vaults just completely exposed to the public internet because it's simply a box that you have to check and say, yeah, okay, I want to expose this. And whether that just be an oversight or somebody not understanding or something intentional, that risk is there, and it's greater because it's harder to control, especially as these environments start spreading and they become a little bit more decentralized. In terms of trusted access, it's much easier to get on. And once you start flattening out those networks and everything becomes a little bit more flattened, pivoting, moving laterally, it just becomes easier. So now if I'm an attacker on your network and I just want, I want all of your credit card data, for example, I can pivot on the HVAC system and gain my way up into your credit card data, for example. And that's a breach that we saw in the United States a few years ago that worked really well, and they're still recovering from, both from a financial aspect, but also reputationally. They may never recover from that. And that's just the reality of us starting to put all of these logically based systems together, and there being room for error, essentially. And then again, for example, unsecured data, status quo for, well, up till today still is TDE. So if I have encrypted my actual server, that's great. But if I have somebody on the network and they want to go to my database and say select all, basically dump all of that data, because I'm on the network and that's trusted and we're still operating within this higher trust security environment, well, that means that I can have all of that data because the system recognizes me as a trusted user. So we need to start looking at how are we going to change all of this at the same time that all of this infrastructure is becoming increasingly dynamic and flexible. Basically, how we start doing that is looking at this idea of zero trust. And zero trust is something that's laid out by NIST initially. And it basically just says that we need to authorize everything. Everything needs to be authenticated based off of the principle of least privilege. Everything needs to be time-based, or credentials need to be time-based and context-based. And there needs to be a very high level of observability so that we can intervene if that's required. But then it becomes, how do you start translating that into the bigger picture? Because if we look at the legacy landscape, well, we started doing that with identity, and that's great, but there were essentially two forms of identity. You could have an IP address, which told you where something was, or you could have, in the case of a human, something like Active Directory, something that could federate, single sign-on, LDAP. And everyone was kind of funneled through that system. There was some sort of challenge, and based off of that challenge, you were granted your identity. Applications using that IP address, well, with this fault domain going up within cloud, I mean, if you look at something like the Lambda function or some flavor of Kubernetes, these things are just meant to run to completion. And then that IP address then gets absolved again, or reabsolved. So then how are you supposed to base an identity off of that? And conversely, is that secure? I mean, it's relatively easy to spoof an IP address as well. So how can we start bringing that in and making that identity more concrete across the board? Because this is what we're looking at today. Well, we have application identities, and it's not like we have one application identity. We have network identities for all of these different things. Maybe there's some overlap with your application identities, okay, but if I'm looking at an infrastructure where I have 3,000 to 5,000 applications, which for a large financial institution is quite reasonable, to be honest, how am I getting the layering that I need and the correct layer, or the correct amount of identity based amongst all of these things? Then on top of that, we have the user identities. And user identities, you know, at least within Europe to date, there's not a whole lot of, there's not a homogeneous standard that states that user identities have to include anything. There is a legislation, for example, coming down that says an identity from Italy has to be able to be used in the Netherlands. So how are we going to resolve all of these things? And that also becomes another part in play. And then cloud identities. None of the cloud identities are the same. How do we unify all of those, make sure that they're acting accordingly, and that we can use them, again, across all of these layers, whether that be cloud, application, user, and how do all of these things, how can they all fit together? So what we're aiming to do with this, and when we're looking at zero trust, is essentially broker all of these things together. Just like we use SSO for human identity, we want to start using SSO for machine identities, so that we can, at any given point, map a particular resource to another resource, and also aid with migration or break glass procedures or anything like that across the board. so that we do have flexibility in the velocity without risking any of our security or undermining our attack surface. So again, securing that access. Now on the application level, we can do that with essentially Vault. So the idea then is to use Vault as that identity broker between machines and applications. On the network layer, if we want to use something like MTLS, that's going to be a little bit of a different protocol. We want to be sure at that point that we have our Envoy proxy on board as well. So then that's going to work with Vault to acquire an identity and leverage MTLS. With users, we're going to need some sort of privileged access management. So how are we going to allow users onto the network? When you're dealing with identity brokering between machines, secrets management, certificate management, things like that, we're assuming that that is an everyday procedure. That's something that occurs on a regular basis, business as usual. So there, if something goes awry, something's not quite following the pattern that it should, that's when we want to know something's gone wrong. Conversely, if we're looking at that user identity, that's something we want to track a little bit more often, because the user intervention is more of a change management sort of issue. Because if I'm a user and I'm intervening into a larger ecosystem, typically that's because there's been a bug, there's been a breach, there's some reason that I as a human need to intervene because something's not quite right, that automation hasn't been executed to completion. So at that point, I want to make sure that I have that session data, that I'm properly monitoring that from the beginning to the end, which is why you would need to use privileged access management over the identity brokering and secrets management. But why are we talking about this today? And why is this so different than it was 2 years ago, 3 years ago, 5 years ago? Well, it has to do with our landscapes changing, right? So at this point, we've all recognized that cloud adoption, it's going to happen. It is happening, and it's happening rapidly, but it doesn't respond to the same security controls that previous architectures did, that previous private data centers did. This change in identity across the various CSPs, again, whether that be on-premise, public cloud, some hybrid of the two, there needs to be a way to unify those two things. Like I said, that private data center is not going away. And because of that, because we have this multi-cloud, hybrid cloud situation and setup, that means that we now have this expanded attack surface. So instead of having the small private data center and that one entry point that we had previously, essentially anything that touches the internet, which in the case of public cloud and in some private cloud cases is pretty much anything, we need to be sure that we have the resilience in place to be able to respond to these things. Because at this point, it's not a question of if you're going to be attacked or if there will be a breach, it's a question of when. So we also need to be sure that we're putting adequate attention on what happens when you're breached and how do you recover from that. So what are some of the best ways to do that? And in general, if you're looking at an attack, it follows a pretty standard pattern each time. Some companies and organizations are going to follow the MITRE ATT&CK framework. Others follow what they call the kill chain. In general, they're very similar. They cover the same ideas, but basically you want to get into the application. You get that initial access, look around, see what's going on there. Once you're in and you understand that, you want to get privilege escalation. So if I go in as a user with read only, I want to figure out a way that I can just get a little bit more privileges. So maybe it's read and write. And from there, if that's sufficient to create an attack and gain credential access, that's great. Otherwise, I'm just going to keep trying to notch it up little by little. So once I get the credential access, that means that I can start moving throughout your environment. And once I'm moving throughout your environment, it makes data exfiltration quite easy. If we look back even just a few weeks ago, this is pretty much exactly what happened with the Uber attack. Somebody was able to get in via social engineering. They were able to then get that privileged escalation when they found credentials in the config file, move laterally, and then exfiltrate that data. And I suspect that they're going to be finding footprints of that attack for quite some time, because it was quite a large attack, and the breadth of that and the attack surface that it eventually was covered because somebody got that highly privileged credential escalation. Yeah, that one, I think it's going to be rough, to be perfectly honest. So how do we start looking at that and say, how do we stop this? How, or at least how can we mitigate this and make the attack surface smaller so that when it does happen, it's easier to go in and rectify, that I'm not having to go in and adjust, individual workspaces and cloud consoles and changing all of my configurations and any kind of sensitive data that might be in there, alerting all of my users, for example. So if we take it back to that attack chain, the first thing we're going to start with is initial access. So how can we make sure that we mitigate that initial access? Well, if we look at IBM, that initial access is most frequently some sort of credential leak. So in that case, we want to make sure that we're rotating those secrets as much as possible. Dynamic secrets are ideal because those are created on the fly. Then they're just injected into the environment, and we can update those as much or as frequently as we need to. So in the case of privilege escalation, again, something that happens quite often. We talked a little bit about having those time and credential bound or context bound tokens and credentials. Again, if a credential or a token can only use that much space, it's going to help pull that back. And if you can do that essentially through something like identity brokerage and making sure that you have complete control and understanding over your total environment, that's going to help you drop that down a lot significantly and make sure that those tokens only have the amount of access, the privilege that's required of them. Credential access. I hate to break it to you, but this happens far too often. Things get pushed to GitHub. I wish I could say that I was innocent in this and that I had never pushed any credentials to GitHub or passed anything over Slack. I would be a hypocrite if I said I had. As a developer, we've all done it. Either you've just typed in a random key because it was easier to do your development around it and then forgot it was there and pushed it and had to go back. And then, the fallout from that tends to be quite heavy, but it's about finding a way to make sure that that doesn't happen. Making sure that any sensitive credentials are stored encrypted for sure, so that if there is lateral movement onto the database, that those are contained, but also making sure that all of that is API driven, so that when your developers are developing or anything else, these things are based off of API calls. They don't need to change anything based off of what they're doing. They just run their environments as they normally would, and that doesn't really change from one environment to the other. You're going to build that into the logic, essentially. I think lateral movement may be one of the harder ones to address. So as you're going down the list of things that you need to do, keep in mind how you're going to manage this lateral movement, because it's incredibly important. But one thing I want to call out is you have to have an identity in place, and you have to be able to leverage identity before you're going to be able to start putting in things like MTLS. MTLS can only happen when both machines can recognize who the other one is and whether or not they're trusted. And you want that to be based off of intentions as opposed to, again, the static IP thing. So put in place your identity first. Then we can start looking at how is this networking piece going to start coming together, because then we can really start doing some really neat stuff, especially if you look at console, things like that. How are you going to elevate just from TLS to MTLS? But you have to be good at identity and PKI before you start doing that. And then exfiltration. I think encryption is something that's on the top of a lot of our minds. How do we manage it? To what scale do we manage it? It's an operation that's typically quite expensive. So how can we find that balance point between the two things? And once you have something that is lightweight enough to be able to generate that on a database level and on a table level, that gets a lot easier. Right, so if you look at this from the HashiCorp lenses, what we really see is that it's a combination of tooling between Vault, Boundary, which is our newer tool, but one that I love, and Console. And these three things united mean that you can implement high levels of identity across the board, not just on an application level or a network level, but really all levels of your cloud operating model. And then plugging in Boundary and Console to make sure that all of that is then unified via machine to machine and also human to machine. So that's really nice. That's a lot of theoretical information. The question then becomes how? I can sit here and talk to you about all of these things all day, why they're important, the different types of breaches that we see, how as an attacker I would want to go through the system. But the reality is I want you to be able to come away from today as well, understanding what's in play and how do you achieve this, essentially. So we're going to start just really easy. Hypothetically, we have service A that needs to talk to service B. Just because it's my domain and what I'm most familiar with, we're going to call it Kubernetes. And we're going to say each one has a JWT token. My disclaimer of the day, please do not run a database on Kubernetes. I am not advocating that. I do not want to see it. It's just easier in this context if we have a little bit more of a homogenized workflow across the board. So before we can even start touching the application, we need to think about how we're going to be spinning up our infrastructure. What does that look like? How are we going to achieve this idea of immutable code? So if, for example, I want to paint my kitchen, I can just tear down the entire house and paint it back up with a new color kitchen, is the idea of this. So how am I going to achieve that so that it's repeatable every single time and there are no questions? Again, coming from where I am within HashiCorp, we're going to do that with Terraform for the infrastructure as code, and then we're going to layer in some Packer for the imaging. What that's going to allow me to do is make sure that I have a golden source of imaging, so that should anything happen, if I need to change out an image because there's a supply chain attack, etc., I know without certainty I can do that across the board and all of my environments will be impacted. Something I think that's really easy to overlook, though, is that even on this fundamental layer, when it comes to infrastructure as code, they need to be able to acquire their own identity. And if nothing else in your system, making sure that your infrastructure as code base has an identity and also can be observable is probably more critical than anything else. And this is because if I, as an attacker, can get access to that, or I can in any way manipulate your infrastructure as code, I'm golden. I can do literally whatever I want to and have your domain. So really make sure that you've properly hooked up your identity, that the proper controls are in there, and you also have the proper observability, auditing, monitoring, logging, all of those things really need to be there to make sure that that base is secure. Because if your foundation isn't secure, the rest of the house just doesn't matter. But we also want to make sure that we have proper observability on the imaging layer as well. It's a little harder to get that identity layer on imaging, but we can do that pretty easily on observability. And again, that's going to help you should you need to change out any image at any given point because of a versioning issue or a bug or even just an upgrade. So once we have these two things in place, they have their identity, they have their observability, we can go ahead and put in that identity brokerage piece. So how are we going to translate identities and resources? We're going to make sure that we do that using infrastructure as code. And the reason behind that is we want to drive out as many hands-on keyboard as possible, especially when dealing with security tools. All of that should be running either via pipeline, infrastructure as code, because humans, we're flawed. We introduce bugs. Some may have malicious intents. We just want to make sure that that is as consistent as humanly possible. Also, we're looking right now at attrition rates of anywhere from 23 to 50% across the board. If somebody leaves tomorrow, you want to make sure that that information and the ability to have the continuity within your systems is still there as well. And I'm sure you're going to be surprised. We want to make sure observability, again, is also there. Now, the next thing I'm going to put in is this connect layer. Now, initially, the connect layer is only there to help me on some levels with my observability, to understand what's talking to what and how it's talking, the health of it. But I'm not going to go straight to service mesh. If I try to go straight to service mesh, I'm going to have some difficulties there. And again, observability is key. So now once I have all of this in place, which is just the base, the foundation, the things that I need to continue my journey, now I can use that infrastructure as code and those images to actually build my application. So I'm going to go ahead and I'm going to spin that up. But you're going to be surprised to hear, I want to make sure that they have identity. That identity, just to be very clear, can come from wherever it needs to. So in this case, I'm using something like EKS. That identity is native, and that's not broken, and it works, and it's industry standard. So let's go ahead and we're going to leverage that, and there's no problem with that. So I'm going to use that JOT to then go ahead and register. Oh, sorry. Both to console, so saying, hi, this is where I am, this is who I am, and also to Vault. And I'm going to say, this is my identity, here's my passport, both for service A and for service B. When you're looking at some of these trust models, for example, you want to know who, what, and where, both for the subject and the object. So it's really important for service A to also be able to know about service B, who, what, and where. And based off of the importance or the needs and the criticality of the actual application itself, maybe one of those things is less important. Maybe we can say hard stop, all those three attributes need to be in place, or we can grow into it and say, okay, I want these three attributes to be in place down the road, for now, who is the most important. And so maybe I'll warn or conditionally deny based off of the other two attributes if they're not in place, so that we can start seeing what's going on. It's really about building things up based off of this identity piece, so that we can start growing this zero trust. Because realistically speaking, looking at these huge environments, it's not going to happen from one day to the next. It's going to take some time. It's going to take some time to register service A with console and then with Vault to make sure that we have that proper observability going. But once they're in, once we've kind of discussed what needs to happen in terms of privileges, what they're allowed to do, if they're allowed to read, if they're allowed to write, etc., we can start leveraging a little bit more of the either dynamic secrets, dynamic certificates. In this case, we're saying, okay, we've registered everything with Vault. We can accurately broker that identity. We're going to make the next step into service mesh, and we're going to make sure that we have that connectivity and that secure connectivity between the two of them. So what we're going to be able to do now is use a proxy with console and register with console saying service A should be allowed to talk to service B. And we're going to issue certificates based off of that. So this is why I said it's important to be good at PKI. And that really has to do with this side of being able to generate these certificates on the fly. Because what we're going to do is we're going to use these proxies, and we're going to allow A to talk to B. And we're going to get those certificates and those identities from Vault. So now, when service A tries to connect to Vault, it's going to say, okay, get me that identity. And we're going to be able to connect there because we had declared that intention previously so that these two applications could speak to each other. Now, if we hadn't declared that previously, that would just be turned off, and that workflow would never be completed, which means that if I'm an attacker coming at you from the side, maybe I'm service C, I'm going to try to connect using a similar pattern to service A. Because I don't have the proper identity, even if I might have, a subnet of the same IP address, it's not a big deal because it's not going to let me in. Whereas if I were a more traditional application, it may let me pass in and move laterally. So it's really about just bringing this down on an identity level. And so now we can do any number of things. We can do secrets management. We can make sure that that's happening. We can also start doing things like encryption and encryption as a service. So now I'm going to pass it to Vault. I want to say encrypt it, and Vault's just going to pass me back something that's encrypted. And now I can really securely pass that, because not only do I have MTLS, but I also have an encrypted cipher. So even if somebody somehow manages to break my MTLS, maybe they do a replay because we're using an older version of TLS, for example. If they get in there, it's still an encrypted value, and it doesn't matter. So what we're essentially doing is making sure that we're layering these controls, which is a concept, I think, which is pretty known within the industry called defense in depth, and just making sure that if one control is breached, or when one control is breached, we have a secondary control there or a compensating control to make sure that that risk then is shifted off of exposing anything or etc. So it's easy to talk about that in the context of machine to machine because we can predict all of that. We can predict that behavior. We understand how all of this works and comes together. The difficulty then comes with adding humans, because humans are unpredictable. They follow their own logic. Logic can be flawed. Maybe they have bad intentions. So then how do we start figuring this out on the human side of things, right? And that's where you have your privileged access management come in, and in our case, boundary. And what boundary is going to do then is, shockingly, sit on the boundary and make sure that there's a nice kind of liaison between the two of them. So now we're going to still acquire our identity, whether that be via Okta, LDAP, etc. There are a lot of tools in that space, and they do them very well. So we want to be sure that we can incorporate with that, essentially. So we're still going to get our identity, and then that identity is going to go to the boundary. And what we're going to do then is essentially shoot you out onto the target. We want to make sure that if somebody needs a resource, if somebody needs access to a resource, they're only getting access to the resources that are required for them to do their job. I think if you look at a traditional environment, typically what we'll do is give you a VPN, and that VPN is going to shoot you out onto the network. The difficulty here is that you can only microsegment a network so much before it becomes unusable. So typically you'll have 3 or 4 microsegments within these larger networks, but it doesn't do a whole lot in terms of preventing lateral movement. So when we look at boundary, what we're aiming to do is to make sure that when we put you on the network or put you on your resource, you're only on those resources that you need. The idea being that you have just-in-time access, so that it's, again, that context-bound and time-bound, and you have the principle of least privilege. So you only have access to what you actually need to, not more. So maybe as a database admin, you do need access to the database in case of a break-left procedure. However, as an app dev, maybe I just need read, or I need to be able to reset a certain field on the database itself. So how are we managing that? And via boundary, making sure that we pull that back so that they can only access what they need. And shocker, that agent then gets its identity via Vault. So it's going to go to the boundary agent, and via Vault, make sure that those credentials are generated just in time, like we were talking about. And then when you're done with your manipulation or debugging or hotfix, that access goes away. Now, what you will see, though, is over time, we maintain observability on all of these things, whether or not these systems are interacting actively with each other or doing anything. We make sure that we keep the observability on there. That's all for health checks, making sure that our environments are running as planned, but it also has to do with making sure that there are no anomalies. So just as it's important to check that things are running as planned and as we need to, we want to make sure that we see that if any anomalies crop up, unexpected behaviors, unexpected users. For me, when I was dealing with secrets management, I wanted to make sure I saw if there were any attempted accesses to vaults or namespaces that weren't within a team's sort of permission or purview. So all of these things are things to take into consideration. And if you sit down with your team, do something like a threat modeling exercise, it's going to help you delineate what's important in terms of observability. Should you have an attacker, or if you're simulating an attacker, what would those behaviors be? What are those going to then translate to on the observability side? So if you're logging, monitoring, making sure that those are logged, and you'll throw the appropriate monitoring and alerting if any of those crop up. It's a lot of information I just threw at you quite quickly. I understand. Before I open it up for questions, I just wanted to say thank you for all of you for joining us today. It's an absolute pleasure to work both with TeraSky and AWS. If you have any questions, you can find us in the marketplace as well as TeraSky, or feel free to reach out directly and we'll make sure that we respond to your questions appropriately. And with that, can I open it up for questions?